All right. Here is 2.2, day 1, part 3. We're wrapping up our lesson. We have one example left. This slide, I'll tell you what I do want you to write down. What we're going to do is we are going to find the zeros of the function to finish off this problem. There are 4 things that you need to know about zeros. We are going to solve these zeros by factoring. Remember how we spent so much time in Algebra 2 a week on how to factor functions? This is one of the key reasons why. It helps us to find the solution to the function. It helps us to find those x-intercepts. So now we're knowing the end behaviors, and we're going to find those x-intercepts. What I do want you to write down is something new. This right here in the green. We don't talk about the turning point. What the turning point is an increase or a decrease, so think about slopes in the function. So you have a turning point. We're going to show you that in the next example. And how many turning points you have is n minus 1. So if I think about, let's say my function is x cubed. So what's the shape of an x cubed function? What do we say that's called for short? A snake. So let's say my snake looks like this. How many turning points can I have at most? 2. Because my degree is 3, I have to take 1 away, n minus 1. I can have up to 2 turning points. And where these turning points are on the graph, here is my left. It's rising, it has a positive slope, and then all of a sudden, it goes down and has a negative slope. So this point right there, the top of that hill, is called a turning point. Later on tomorrow, we're going to call those relative maximums and minimums. Then we have another slope change. It goes from a negative to a positive. So we have another turning point right there. So you can have at most n minus 1 turns. So the degree was 3. We get to take 1 away, so we can have 2. The second part, which we do talk about in Algebra 2, is you can have at most n zeros, which leads us to x-intercepts. That's the important key to graphing, is finding those x-intercepts. So since my degree is 3, how many x-intercepts can I have? I can have at most n zeros. So what's my degree? 3. So I can have 3 zeros, or in graphing world, 3 x-intercepts. Sometimes it doesn't happen. Sometimes you might just have 2. And we'll talk more about why that might happen tomorrow. Why you might just only have 2 x-intercepts instead of 3. And that's leading us into multiplicity zeros or repeated zeros. Everyone had a chance to write down the little squiggly part in the green? Okay, we're leading to our last example. This is what I do want you to write down. This is something you will see in your homework, is this multi-step problem. Finding the zeros. Here's our last example. We give you a function, and I just want you to think in your head, you don't need to write them down, these 2 questions. How many zeros can this function have, and how many turning points can it have? Think to yourself. And then we're going to go ahead and find those zeros on this smartboard. Please write down the function, though, for this example. All right, who would like to share with me, how many zeros can it have? Up to how many? Very good, 4. How do you know that?
Because the degree is 4.
The degree is 4, and I tricked you, I changed up the order. The degree is 4, so I can have at most n zeros. So how many x-intercepts can I have? up to 4. Part B, how many turns can I have? Skylar. I can have up to 3. Because my degree is 4, I have to take 1 away, so I can have up to 3 turns. All right, we're going to go ahead and find the zeros of the function, which in the end are our x-intercepts, where they cross the x-axis. So I do want you to follow along and do this in your notes. Step 1 is to set the function equal to 0. Then think about your factoring rules. See if you can factor this function on your own. So you try that one on your own. I'm going to take a new volunteer to finish this step. I'm not sure if there's any chocolate left. Mr. Leonard's been in here a lot lately, so I might have to dig down. Anyone like to volunteer to factor this equation?
When you take out the GCF.
Very good. You'll take out the GCF. Yeah. Brandon, you want to do it? All right. It's all yours. The rest of you are at your desk.
You start way up here and
Yep. You can write it right there.
so out the GCF.
So you pull out the GCF x squared. Now he's left with a trinomial, and its leading coefficient is 1.
You do your chart method with those ones.
Very good. So I call that method of factoring the chart method or the t-chart method.
You get x plus 2
So what are the factors of -2 that add to -1? What are the factors of -2 that add to -1? Awesome. Give me a thumbs up if you got that right. Or you took out the GCF. Awesome. Thank you, Brandon. All right, the next step is to use that zero product property. So we're going to set each of those factors equal to 0 and solve for x. This is where they go fast. So what's one of my factors? X minus 2. Okay. So we set that equal to 0. What's another factor? 0, be a little more specific. I think you're already solving it. X squared is a factor. And what's my third factor? X plus 1. And now we're going to solve these for x. So how do you solve the first equation? Square root it. So when we square root that, plus or minus, well, plus or minus, square root of 0 is still 0. So x equals 0. I want you to put a 0, 0 there for today. Tomorrow I'm going to talk about what that 0, 0 does for the graph. It's called a repeated 0. But for today, just write 0, 0. Then, how do you solve the next one? Add 2. So x equals 2. And then the last one, subtract 1. All right. The next step, those are your zeros. There was 4 of them. One of them is a repeated 0, 0, 0. That's not going to show up as a double x-intercept. So then we want you to identify these as x-intercepts. We want you to write them as ordered pairs or coordinates. So what would be one of the ordered pairs? 0, 0.
2, 0.
2, 0.
Negative 1, 0.
And then negative 1, 0. All right. You've spent some time with the graphing calculator today, so we'll just save a little bit of time. And let's just check and look at this graph. It's not a symmetric W, but that's okay. But we can pick out the turning points. So if you wanted to graph it, or we can just look at it. So we have an x-intercept here of 0, 0. We have an x-intercept here of negative 1. We have x-intercept here of 2, 0. Then remember, the turning points are the changes in the slope from increasing to decreasing or vice versa. So this is a negative slope. And then all of a sudden it curves to a positive slope. So this point is called a turning point, or the relative minimum. Then we go from a positive to a negative slope. So there's another turning point right there. And then our last turning point, going from a negative to a positive slope, its turning point is right there. And then there's our x-intercept. All right. Tomorrow we're going to continue this lesson, focusing on how to use it without the graphing calculator. I'm going to give you some more tools tomorrow, and then tomorrow we won't be using the graphing calculators. So stay tuned. Here is your homework for tonight. So go ahead and write that down, and then we'll come back together and work on some homework questions you might have on quadratics.